Welcome to this little video that is an overview of the testing algorithms that are built into the OPI R package. So there's 5 main algorithms that are pre-programmed. There's Zest, Quest, which is really just Zest choosing the mode of the probability distribution rather than the mean, Full Threshold, as was used in the original Humphrey field analyzer, 4.2, which is a staircase procedure, quite similar to Full Threshold, and finally method of constant stimuli, or MOX, where you can either do a forced choice multiple interval experiment or just a simple yes-no method of constant stimuli, like is often used for measuring frequency of sine curves. So the first 4 of these all have 2 implementations. One is a stateless and one is a state-based, and the MOX keeps its own internal state. What does that mean? A stateless version operates just like a function. So we can see an example down here. We can call Zest with some, I'll explain this make stim function in a minute, and it'll go off, do a series of presentations depending on what parameters you've given to the Zest procedure. In this case, we're just using the default parameters. It'll go off, collect responses, and come back with a result. Similarly, we could call Full Threshold. It'll go off, do some presentations, and come back with a result. So this is good for single locations, if you just want to test one location, or when the spatial order of presentations is not important, you can fully threshold one location before moving on to the next. Often in simulation, that's the easiest way to do it when there's no need for any spatial logic. But in reality, or perhaps in various different experiments, you need to interleave multiple full thresholds or multiple Zests at different locations. And so after you've done one presentation at one location, you need to remember the information about that location for some future time when you come back to that location and test another single presentation. So that is, you need to store the state of that location. So to allow that, the Zest, Quest, Full Threshold 4.2 also have 4 parts to them: a start, a step, a stop, and a final. So when you need to interleave multiple locations, here's an example down the bottom. We can use the ft.start function to initialize our full threshold at some location. The location is buried in this thing here. I'll explain in a minute. And then here we have a loop that goes around while not ft stop, step, which does a single presentation and gets a single response. And so this would go round and round and round until this one location is finished. And then at the end, we call ft final to get the final threshold. So if we were using multiple locations, we'd start multiple versions. So we could have a whole list of states. We could loop around randomly choosing those states and stepping them until all of them are finished. And then we can pick up the final thresholds. So all of these, whether you use the stateless version or the stateful or the state-based version, all of them have got this make stim thing here, right? So let me explain what that is. We know that OPI present needs a list of class OPI static, temporal, or kinetic stimulus in order to present a stimulus. If you haven't seen this already, you should go back and watch the previous video. So within a procedure like Zest, Full Threshold, MOX, etc., we need some way of constructing these lists at the value that the algorithm has chosen. So the Full Threshold procedure might want to present at 25 dB at some location. It needs to know how to do that. It needs one of these lists. So we achieve that by giving Zest or Full Threshold or MOX a make stim function, which can turn its desired value into one of these lists. So the makeStim is a function that takes two parameters, except for mocks, it's a special case I'll show you later. The first one is the stimulus level that the procedure wants to present in the units of the procedure. So for full threshold, that's dB. For zest, it's whatever domain you're using for the zest. Usually it's dB, but you might decide to do your zest in candelas, or you might decide to do your zest in some other linear units, like some people have done in the literature, Stuart Gardner most notably. The second parameter is the number of presentations that have been used so far. So the zest, the full threshold, whatever, will call this function with these two values and expect you, the makeStim function, to return the right sort of object. So here's an example for full threshold. The function, it takes the two parameters, in this case a dB, n, I mean you can call them whatever you like, but there has to be two of them. Builds the stimulus list using the dB value provided, and then returns it. So in this case, n is not even used, but it still has to be there in the definition, because zest, full threshold, etc. is going to call this function with two parameters, and R will get grumpy if you don't obey. And note that you could return a kinetic stimulus or a temporal stimulus depending on what you're doing. And another little gotcha is be careful when converting. So OPI present needs a candelas per meter squared value as the level. So just be careful when you're doing your conversions that you're using the right dB scale. So that's the general anatomy of this makeStim function. If you can see here that the location of the stimulus is hard-coded. So if you wanted to do a procedure with multiple locations, then you'd have to create multiple makeStim functions. So we've got one here for location 1, which has got x and y at 9, 9. Then we've got another function for -9, -9, and so on. If we're doing a 24-2 pattern, we'd need 52 of these functions. Everything else is the same in these functions except for the x and y. And note, we're taking in the two parameters, we're converting the dB, and etc., etc. So if we were building a procedure, a state-based procedure, we'd say, okay, the state for location 1, we're starting an FT, a full threshold, and the makeStim function is m location 1, this function here. For location 2, we're creating a full threshold, and the function for making the stimulus will be here. Then we'd have a loop of some sort, so while location 1 has not stopped, or location 2 has not stopped, randomly choose one of them and step them. So either step location 1 or location 2. This might not work too good if you try and step a location that's already finished. You might need slightly more sophisticated logic here, but you get the idea. This is pretty ugly if you have to cut and paste 52 functions and make sure you get all the x and y values right. It's probably better to do something a bit more like this, where you create a makeStim helper, which takes an x and y as parameters and builds the makeStim function for you. So then we can say our makeStim for lock 1 is makeStim helper 9, 9. We give it the x, y. The makeStim function for location 2 is makeStim helper -9, -9. So this makes life a bit easier. There's a couple of tricks in here, and this is all in the help file in the R package, but basically what we're doing is we're creating a fake function. So it's taking, our makeStim function has to take two parameters. We're just making any old function. All it does is add these two together. It doesn't really matter what it does. But then we're substituting the body of this function with the stimulus list and the stimulus class. But in particular, x and y are coming in from these x and y here. So this is the substitute. We're substituting this x for this x, which is this x. And we're substituting this y for this y, which is this y. Don't worry too much about it, but there you go. So that makes life a bit easier. So that's the key to getting these inbuilt procedures working, is to have one of these makeStim functions where you specify both the location, the size of the stimulus, and all the other stuff that you need for a stimulus presentation on a real perimeter. So details more specifically about each procedure. Zest and Quest, they have a bunch of defaults. So you saw back here that I ran them just by calling with a single parameter. So all of the other parameters are set to the defaults, which includes a uniform prior, a fairly steep cumulative Gaussian likelihood. So these are all explained in the help file. Just note that in your Zest and Quest, if you're keeping a PDF, the domain over which you keep your PDF might extend beyond the range of the machine. So for example, it's often the case that the lower limit of your domain might be less than 0. So I've run Zests in the past where the PDF is kept over -5 up to 45 dB. But of course, -5 dB doesn't actually exist. By definition, 0 dB is the brightest of the machine. So you have to use these parameters, min stimulus and max stimulus, to say if the mean of your PDF is lower than this, then use this as the stimulus. And if the mean of my PDF is bigger than this, then use this as the stimulus, just to make sure you don't confuse the machine. Quest is exactly the same as Zest, but use sim choice of mode. You can also use medium if you feel like experimenting. I don't really know what that's called. It's not Zest or Quest, but it's a Bayesian procedure using the median. And finally, just remember that the makestim function is taking in a value from your domain, which is usually dB, but it doesn't have to be. Full threshold, a lot less complicated, a simple staircase as Humphrey designed it. The default starting guess is the only real parameter, which is set to 25 dB, but you can override that. And makestim assumes a dB value. Mock's a little bit more complicated because we allow for 2 alternate force choice, or 3 alternate, in fact, any number of alternate force choices, in addition to yes-no procedures. So the parameter for Mock's is a matrix with 1 row in the matrix for every location and stimulus level you want to attack, the constant stimuli you want to present. And then the makestim parameter for Mock's takes a whole row of the matrix. So it doesn't take 2 parameters, it takes the whole row. Here's an example. So in this example, we're just dealing with 1 location. So the columns are X, Y, location number, that can be just for your own purposes, number of repeats, the list of stimuli you want to present, and the index of the correct one. So in this case, this is a simple yes, no. There's only 1 stimulus being presented, and so it's always the correct one. So you can either see it or you don't see it. If you see it, you get a 1. If you don't see it, you get a 0. So here at this location, we're showing 10 repeats of 23, 10 repeats of 24, 10 repeats of 25, and so on. So it's like a little mini frequency of scene curve determinant around 25 dB. More complicated, if you wanted to do a 2 alternate force choice, then you now have 2 stimuli for every presentation. So in this case, at location 99, we're going to show 23 dB and 25 dB. The order will be randomized 10 times. And then the response coming back will either be, I saw it in the first one, or I saw it in the second one. In fact, the task here is to choose the brightest. So the respondent, the participant, has to say which one was brighter, first one or second one. And we know that the correct answer is the first one. 23 dB is brighter than 25. I just switched them around here to demonstrate. Here, 23 is brighter, and that's position number 2 in this list of stimuli. The order that they get presented in gets randomized. So this is just artificial. We could have just kept the same order. I just put it there to show you what's happening. 4 different locations. What's the brightest? So I hear those of you who haven't fallen asleep asking, if they're seeing 2 things and you're asking them to choose which one is brighter, but you've only got a single button on the octopus or the Humphrey or whatever you're using, how does the machine know so in every interval, we've got two choices here. Which is the brightest? Was it the first one or the second one? So for those of you that haven't fallen asleep yet and been paying attention, you say, well, how is the patient or the participant going to signal which interval when they've only got a single button to press, right? On the octopus or the compass, you've only got a button. So the short answer is they can't. You have to use some other input device. So you might present the stimulus on the perimeter, but you either need to use a game controller or the keyboard to get back to responses. So the OPI server for Octopus 900 has got some code in it to accept responses from an F310 Logitech game controller, so like an Xbox. We've used it successfully in our lab. I'm not sure if anyone else has. I know Stuart Gardner tried, and I don't know if he got it working or not. Again, a little open source software, you're getting what you paid for. You can also use the keyboard as a response. And under Windows, that gets kind of yuck. Under Mac, it's much easier. And under Linux, it's much easier, but can be done. See the example in the help file. So finally, that's the algorithms themselves. Of course, if you're building a real test procedure in inverted commas, there's lots of other bells and whistles other than just the stimuli that get presented at which location. So you might want to do catch trials for false positives, false negatives, blind spots. You have to program all those yourself. You can call OPI present. You can mix it up with the procedure. A bit harder with mocks, but with the others you can. You might like to have variable response windows. So if the participant's responding very quickly, you might like to speed up your interstimulus interval. If they're responding quite slowly, you might like to make the interstimulus interval longer. Again, program it yourself. Mox has got some parameters that will control that for you. Spatial logic, if you want to use a growth pattern or some locations are dependent on others, then there's some code on the website, the OPI website, which shows how to do that. If you want fancy printouts, well, talk to Ivan about the visual fields package. If you want fancy interfaces, well, a couple of people, Ivan and Giovanni, have both built shiny interfaces that sit on top of the OPI package. And hopefully they'll be available on the OPI website or as part of the visual fields package, one or the other. If you want to do speech feedback, so you don't have to have button pressing, or you want to do speech recognition, yeah, well, okay, good, go for it. You're definitely getting outside the OPI now. This is just an interface to let you use the perimeter. You can build on top of it whatever you like. Eye tracking, so obviously the compass has built-in eye tracking, and the 0900 has video monitoring of gaze, as does the COA. For the 0900, it's possible to dump the video feed of the gaze camera out to a file using the gaze feed parameter. And if you build any of these fancy things on top of OPI, feel free to send me them as examples and I'll stick them up on the OPI website for others to use.